So we are going to go over how to analyze hyperbolas that are not centered at the origin. So this is where we left off on Thursday. Um, so on your packet, because a lot of you are going to be out for the AP test, so I want to get this in on video because you're going to miss this. We're going to do a little mini lesson on analyzing hyperbolas with centered HK. Now, this process is exactly the same as doing the parabolas that are not centered at the origin and also doing the ellipses not centered at the origin. The hyperbolas not centered at the origin follow the same kind of method. So if I had a hyperbola that looked, so if here's my coordinate axis, okay, let me actually use blue. If that's my coordinate axis, okay, but let's say my center was not the origin. Let's say the center was now right here. Let's say the center was right here. Okay? The center would have the coordinates HK. Okay? My vertices, this one would be at H plus A, K. And then this vertex would be at H minus A, K. Okay. And then if I had a focus, so hold on. Let me just make it right here. So this is H plus A, K. And this is H minus A, K. Then if I had my two foci are on the inside. And then this foci would be H plus C, K. And this foci here would be H minus C, K. Okay. Now, your vertices, the asymptotes. So remember the asymptote for this type of hyperbola, if it was centered at the origin, had the, this was y is equal to negative, y is equal to negative b over a x, and then this is y is equal to b over a x. But guess what changes when I just move my origin? Instead of just y is equal to negative b over ax, this becomes y minus k is equal to negative b over a x minus h. And then this asymptote here becomes y minus k is equal to positive b over a x minus h. So this is all on your paper here. It actually shows all of the properties. Now, I did spot a mistake, and I'm going to tell the class this, so hopefully you could see it too. The thing that I copied on the internet got the equation and slope wrong for the second one. Okay? So this hyperbola up here is supposed to go with the first column here. Now, the hyperbola that goes with the second column is the one that has the the transverse axis as parallel to the y-axis, and that goes here. However, they did something wrong here, and this should be a over b and a over b x minus h. So, as you can see, nothing really changes from having the hyperbola centered at the origin. All you really do is the same thing we did with the parabola and ellipse moving. It becomes y minus k, x minus h. So the second drawing that you could draw here, so you could draw this on the right side so that it matches with the right column. Okay. Here is your axis, but now your hyperbola will go like this, and it's not centered at the origin. So let's say this was your center. Okay. If this is HK, then I know my two vertices. This one is going to be HK minus A, and this is going to be HK plus A. And then if I had my two foci, this foci here is HK minus C, and this is HK plus C. I also realized that this table that I copied kind of sucks. I just realized it. So there's actually a better table on page 683 in your book on the bottom that is a better representation. I should have used that one. But all you have to really remember is if you look at the graph that I just take my center, and if I'm going up, I am adding to my y value. For my vertex, I'm adding A, and to my foci, I'm adding C. If I'm going down, I'm subtracting A, and I am subtracting C. Okay? And then my asymptotes have the equation of so once again, like I said, this is wrong here. This should be y minus k is equal to a over b x minus h. And then this asymptote should have the equation y minus k is equal to negative a over b x minus h. Okay? But everything is really explained on page 683 on the bottom. But remember, all you have to do is remember your hyperbolas that are centered at the origin. And then all you do that changes when you have the hyperbola is not centered at the origin is wherever you see a y, you replace it with y minus k. Everywhere you see an x, it is x minus h. Okay? So now let's actually go and do example 7. Okay? Example 7 says we are going to find an equation. So we're on the next page now. Find an equation for the hyperbola with center at -1, 2. So this is example 7. Your center is 1, -2. And you have one focus at 4, -2, and a vertex at 3, -2. Well, you have a graph here. So on your graph, you should see that my center is at 1, -2, my focus is at 4, -2, and my vertex is at 3, -2. So I know that my transverse axis is parallel to the x-axis. So looking here, if this is my center at 1, -2, I am 2 away from my vertex. So A is 3, and A is 2, and I am 3 away from my focus. So C is 3. So A is 2, C is 3. So now I know that I'm going to find B squared, and B squared is equal to C c squared minus a squared, okay? So this is b squared is equal to 9 minus 4. B squared is equal to 5. I square root both sides, and I get b is equal to plus or minus 5. Okay? So I actually have all of the equations that I need, all the stuff that I need to find my equation. Since it is parallel to the x-axis, the x goes first, so it's x minus h squared over a squared minus y minus k squared over b squared is equal to 1. And then I just plug everything that I know here. My center is at 1, negative 2, so this should be x minus 1 squared. My a is 2, so this is 4. This is minus y. My k is negative 2, so this becomes y plus 2. B squared is 5, and it's equal to 1. So that is my equation. If I want to graph this, if this is my center, then I know going to this way, I have my other vertex, and over here I have my other foci. Should be right here. Now, my asymptote. Okay, so we have to kind of be careful with the asymptote now. So the asymptote, when it's parallel to the x-axis, has the oh no. Sorry, my bad. Remember, all I do is, if b is plus or minus square root of 5, I forgot the square root here. Square root of 5 is around 2 point something. So what I am going to do is make my b right here. And remember, I am going to make my rectangular box from A to B, A to B. And then my asymptotes go through the box. And so my parabola my hyperbola opens like that. Okay. So that is example number 7. So these points here, I just take the 2, I add root 5, and I take the 2 and I subtract root 5. And then my A are my vertices, so that is my box, and I could draw the asymptotes. And then all I do is I draw my hyperbola. Okay. So now, why don't you try the DIY, and then I'm going to go ahead and do it. So pause the video while you try the DIY. So the DIY, I'm finding an equation for the hyperbola with center at 4, negative 1. So my center is 4, negative 1. My focus is at 7, negative 1. And my vertex is at 6, negative 1. So if I draw this on my diagram, I see that so I see that my hyperbola is again parallel to the x-axis. So I know that my A is 2 and my C is 3. Okay. So once again, I'm going to find my B squared. B squared is equal to C squared minus A squared. And so this is equal to 9 minus 4. B squared is equal to 5. So now I just have my equation. my equation, since it's parallel to the x-axis, is going to have the form of x minus 8 squared plus y minus k squared. And this is over a squared, and this is over b squared. So my center should be x minus 4 squared over 4 minus, that was my bad, it should be a minus, 5 plus 1 squared over 5. So that should be my equation for the hyperbola. Now if I graph this, I know if this is my center. For 2 away, I'm going to have another vertex, and 3 away, I'm going to have another focus. Okay, and from here, I'm going up root 5, so b is equal to plus or minus root 5. So I know I am going to go, it's a 2 point something, my b. So I know from the focus, I'm going to go up 1, up 2, and a little bit beyond the 2. And I'm going to go down 2 and a little down from here. And then I'm going to go ahead and draw my rectangle. Okay. And that tells me the opening for my asymptotes. Okay. And then from the vertex, I go ahead and draw my hyperbola. Okay. Now let's do example 8, where I analyze the equation negative x squared plus 4, all that jazz. So, example 8. Example 8, I have the equation negative x squared plus 4y squared minus 2x minus 16y plus 11 is equal to 0. So, I'm going to clean this equation up a little. Remember that in order to complete the square, I need a coefficient of 1. So both of these, I have to take out something. So here for the x's, I am going to take out a negative. So this is x squared plus 2x. Remember, I need a coefficient of 1. For the y's, I'm going to take out a 4. This is y squared minus 4y. And then I'm going to send the 11 to the other side. It's negative 11. Okay? So now I'm going to complete the square. This is x squared plus 2x. 2 divided by 2 is 1. And then this is plus 1. And then this is y squared. I'm going to divide negative 4 by 2. That's negative 2, and I'm going to square it. So this is negative 4y plus 4 is equal to negative 11. Be careful of what I add on the right side. Negative 1 times 1. I add a negative 1. And a 4 times 4 is a plus 16. Okay? So this becomes negative x plus 1 squared plus 4y minus 2 squared is equal to 4. Okay? Now, what I'm going to do is I'm going to divide everything by 4. And this becomes negative x plus 1 squared over 4 plus y minus 2 squared over 4 is equal to 1. Now, this is a perfectly fine equation, but we're used to having the subtraction in here for it to be a hyperbola. So what I would suggest, so that you won't get confused, is to switch these terms around so the subtraction is in the middle. So what I would do is I would do y minus 2 squared over 4 minus x plus 1 squared over 4 is equal to 1. You just have to recognize that that subtraction sign means it's a hyperbola. Okay? So now what I know is, I know a couple of things. I know my parabola is centered at 2, negative 1. Oh, did I mess up somewhere? Sorry, this should be a 1. Okay, that's better. So now I know my a squared is 4. So that means a is equal to plus or minus 2. And since y comes first, I know that I am going to go, my transverse axis is the parallel to the y-axis. So if a is plus or minus 2, I'm going to add that to the y value. So my vertices are going to be 2 and 1, and also 2, negative 3. Plus or minus 2 to the negative 1. Okay? Now, to find C, I'm going to use that equation to find C squared that I've always been using. So here I know B squared is equal to C squared minus A squared. So this is going to be 1 is equal to C squared minus 4. I add 4 to both sides and I get 5 is equal to C squared. So C is equal to plus or minus root 5. Okay. And then so my foci are going to be at 2, negative 1 plus root 5, and 2, negative 1 minus root 5. Okay. So that is how you analyze this equation.